All right, so yesterday we talked about the shifts that happen with exponential functions. I know just by looking at g of x, what's my shift? Down 2. What else does that tell me other than what my graph should do? Why is the down?
The horizontal.
Good, thank you, Sai. So because there is a shift vertical, this changes my horizontal asymptote. Okay, it also changes the range. So that's why it's important to identify that. On your quiz, it's not going to be a parent function and then a shifted function. It's just going to be a shifted function. So make sure that you're looking for your vertical shift, whether the adding or subtracting of a number after the exponent, like separate from that little base. All right, so if I were to graph this first, x and y would be -1, 0, and 1. 2 to the -1 is 1/2. 2 to the 0 is 1, and 2 to the first is 2. So 1/2, 1, and 2. Now that looks almost like a line, so be careful with these, that there's not a lot of growth there between 0 and 1. You have to know this is exponential. So if that means plugging in a second point, like if I plug in 2, I go up to 4, and you want to do that, that's fine. But one way or the other, you need to get that swooping shape, okay? So exponentials cannot be graphed like lines. They have to have that swoop shape. So now if I did this, I could shift everything just down 1, 2 points. 1, 2, 1, 2. Or remember, you won't have both on your quiz. So I would also do 2 to the -1 minus 2, 2 to the 0 minus 2, 2 to the 1 minus 2. 1/2 minus 2 is -1.5. 1 minus 2 is -1. And 2 minus 2 is 0. So again, you won't have a parent function and a shifted one on your quiz. You're just going to have the shifted one. So make sure you know how to graph from there. It's also going to ask you for domain. Domain for both is what? -infinity to positive infinity. Every single exponential function. Domain is -infinity to positive infinity. That is an answer on your quiz. Every single exponential function is -infinity to positive infinity for domain. Today we're going to get into logs and it's different. But domain for exponential is always all real numbers. The range for the first one is 0 to positive infinity. The range for the second one shifted down to, so it's 2 to positive infinity. The y-intercept, if I plug in these same 3 points, will always be the one in the middle. So the y-intercept here is 0, 1. The y-intercept here is 0, -1. So if you plug in the same points I gave you, you'll already have your y-intercept from the coordinate points. Questions on and the horizontal asymptote. Horizontal asymptote here is y equals -2. Horizontal asymptote here, y equals 0. Remember, it's a y equals, it's an equation, you need the y equals. Questions? Okay. Then comes the interest problems. So remember, there's 2 equations here, and I will give these to you. A equals P times 1 plus R over N to the NT for a certain number of times a year, and A equals PERT for my continuous compounding. So number 2 says determine the balance for $3,200 invested at 2% for 20 years, compounded A monthly and B continuously. So this is my P. 2% makes my R 0.02. You got to move your decimals twice. And T is now 20. So if you remember yesterday, our T was like only 2. There wasn't a whole lot of growth because it was only 2 years. Something with 20 years should have some serious growth, okay? So this is going to be P, which is 3,200 times 1 plus 0.02 over, what would be N if it's monthly? 12. And then N times T, so my exponent's 240, okay? Again, if it's scientific, it's easy to just do 12 times 2, but if it's you're graphing. But if it's scientific, you want to multiply out that exponent first. 3,200 times 1 divided by, or 1 plus, sorry. Open the parentheses, 0.02 divided by 12, close again, and then 240 $4,772.25 because we round to the nearest cent. Then comes yeah.
Will we ever have to find like P or R?
Probably not in here, but those are great standardized test questions. So like the one on my, not that we're talking about it, but on the PSAT, right? There was something about like doubling your money, right? Or even think about a half-life. Half-life is half of it, right? It's the same thing. It's the same growth, except the other side, instead of saying, I mean, it doesn't even matter how much money it is. If it's double it, so if I wanted to know how many times it would take to double this money, I would set this equal to 6,400 and my t would be my variable. So we divide both sides by 3,200, you'd get 2 on the other sides, which should make sense because that's doubling, right? And then you'd work backwards from your exponent, which uses logs, which is what we're going to get to today. Yeah. Okay, so then continuous is your PERT. Oops. Which is 3,200, ER 0.02, T 20. So 3,200 times E to the 0.02 times 20. And I get $4,773.84. So not a big jump there because monthly is pretty often, okay? But obviously the continuously should still be more than the monthly. Yeah. Sure. So this, again, won't be on your quiz for next week. I'm going to save the calculated questions for your test. Okay? The graphing, definitely. The simplifying exponential functions using the base, making the base the same, the one-to-one property, that you'll definitely see next week. These I'll save for your test. All right, so let's talk log functions, okay? Which is all of 3-2. So logs and exponential functions are inverses of each other. Everything we talked about with exponential, think about like there's a horizontal asymptote, we switch it to make it a vertical asymptote. There's a y-intercept, we switch it, make it an x-intercept. So these are inverses of each other. The x is the large part of this, has to be greater than 0, and so does the a. So the little number on the bottom, which is called the base, is not going to be negative, and it can't be 1, because that is going to become the base of your exponential function. So if I have an equation like this, y equals log base a of x, which is how that's read, then I convert it into exponential function by taking the base of my log, the little guy, going over to the other side of the equal sign and picking up that y, and then the log drops off and leaves the large number by itself. So when I teach this, I say logs are like high school relationships. They never stay together. Now, I'm not talking, somebody in this room is offended, somebody at home is like, not my relationship. I'm not talking about yours. Yours will stay together forever and ever and ever. Most high school relationships, however, do not, which is why we remember logs like that. So the pairs of logs, whether I'm going from exponential to log or log to exponential, the pairs never stay together on the same side of the equal sign. They always split. So from a log, if I had log base 2 of x equals 4, the 2 comes over and picks up the 4, drops off, leaving the x by itself. If I work the other way, remember the pair never stays together. So the 2 and the 4 split. The 2 is called the base of this function, so it becomes the base on the log. The 4 goes to the other side of the equal sign, and the x joins the 2. So you are going to have to know quickly how to get from one to the other, because this is how we end up simplifying logs, okay? So this is my log expression or log equation, and this is it in exponential form. You'll know it's in log form because it will have the word log in it. It's very obvious, okay? First thing we're going to do, and I promise you this is not going to be a test question, is just work on the conversion of them, okay? So log form would be y equals log base b of x. The b would come over, pick up the y, leave the x by itself to give you the exponential form. If I'm working backwards, 2 to the 3 equals x is a true statement. They have to be a true statement if they're all numbers. This is called the base of that exponential function, so it becomes the base on the log, which is the bottom part. The 8 comes over with the 2, and the 3 gets bumped to the other side. So there are times when you're going to have to work from log to exponential, and then times when you're going to go from exponential to log. All right, so this one just says, write each equation in the equivalent exponential form. So if I look at A, the 2 comes over, picks up the 4, drops off, leaving just the x by itself. So we don't need to solve these yet. We're just rewriting them. Eventually, we're obviously going to solve these, but just now we're just rewriting. The second one, the 3 comes over and picks up the x, drops off, leaving the 9 by itself. Easy stuff, right? Okay, work the other way. Now we're in exponential form. We need to write it in log form. So the b is called the base. It goes log base b. 16 comes to that side, 4 bumps to the other side. B, 5 is now the base. X joins the 5, 2 gets bumped to the other side.
Go back to the slide.
Mm-hmm. So I made the f of x the y, and then the 4 comes over, picks up the y, drops off, leaving the 64. Now again, as we get good as powers of numbers, especially because a lot of them are going to be around the same things, hopefully we know that 4 to what power is 64? 4 squared would be 16, 4 to the third, 64. So y equals 3. If we don't know that, then we take 64 and we break it down, right? So let's say this is 4 and 16, and that is 4 and 4. That means if I wrote it 1-to-1 property, 4 to the y would equal 4 to the third, so y equals 3. But again, you're going to get so good at logs, I have faith in you. You're going to get so good at logs that you'll be able to look at this expression here and say, 4 to what power gives me 64? My answer's 3. I'm done. Okay? That's the kind of mental math you want to happen. All right, B, log, so y equals log.
Wait, so what's the answer for that?
Just 3.
Oh, it's just 3?
Yep.
Okay.
So B says, if I rewrite it, y equals log base 36 of 1/6. Now the 36 can come over, pick up the y, equals 1/6. How the heck do I get from 36 to a fraction?
Negatives.
I got to get a negative. How do I get from 36 to 6? Close.
Is negative 1/2?
Where?
Square root, which is 1/2. Okay? So the quick way is y equals negative 1/2. The long way is change a base. So this would be 6 to the second raised to the y. The right would be 6 to the negative 1. 2y would equal negative 1, and y would equal negative 1/2. How you get there is completely up to you, but obviously the faster and more comfortable you get with these, the easier it's going to be. If I am square rooting, then my exponent is 1/2. If I was cube rooting, it'd be 1/3, right? If I'm going from a whole number to a fraction, it's going to be negative. So those kind of tricks you want to start to pay attention to. So this answer here is just negative 1/2. All right, using a calculator. So again, think test prep. Week after next, obviously for homework you need this, but week after next is where you would see this stuff. Your calculator has a log button. It is directly over the ln button on a graphing calculator. It is next to the ln button on this one, okay, which is what the ln is, where the e is, right? And it is, I hit second here. It is next to the 4 on this guy. Okay. That log is log base 10. So log by itself is log base 10. The common log is what they call it, is log base 10, okay? You cannot do change of base on most calculators. Like I can't do log 3 of 2 by changing this little number on most calculators. Some actually do it, but most of them we can't do it. That we're gonna learn how to do a different way. But if it is log 1,000, like this one is, okay, and I literally hit log 1,000 and hit enter, it's 3, which should make sense because 10 to what power gives me 1,000. I need 3 zeros, so my x is 3. If you see something like this, log of 5 over 2, now this tells you 2 different ways to do it. Here's with the scientific, here's with the graphing. With your graphing, you could literally hit log of 5 divided by 2. Inside the parentheses, the 5 divided by 2 has to go. And you get, it's here, 0.39794. If it's scientific, like your phone one, you have to do 5 divided by 2 first, then hit log. Okay, so again, you want to practice with both and make sure you understand it. Log 5 over log 2 means on the graphing calculator, hit log of 5, close your parentheses, divided by log of 2. Then hit enter. And then log of -3, there is no way for a base that is 10 to become a negative number. So this would be a no solution. Your calculator will give you an error, okay? You cannot get a result of a log to be negative. We just heard the same thunder, Sai just said. I hear thunder outside. I don't know if I'm going to get kicked out. It's also thundering here. So again, my advice is to make sure you practice this on a scientific calculator and then a graphing calculator. Make sure you know how to do these things because you're going to need to know how to get those errors. All right, so use a calculator to evaluate the function at the indicated value of x. So -3 log base 10 is the same thing as log of 2.7. So I literally on a graphing calculator type that right in. -3 log 2.7, and you get -1.294. If it doesn't tell you to round, usually it's 3 decimal places. On this guy or your phone, you're going to have to do 2.5, then hit log, then multiply it times the -3, and you get the same answer. 2.7, sorry, 2.7. Yes.
So we're not inputting the number 10 as a base for this one?
No, your log button is 10.
Oh, so it's already at a base of 10. Okay.
Correct. All right, some quick properties that help us with the mental math portion, okay? If your answer to a log is set equal to 0, my answer is 1 because, right, this base, oh, geez Louise, this to the 0 power equals 1, which means anytime I see log of any number where the big part of my statement is 1, my answer is 0. Right? Because I'm saying, how do I get this number? What do I raise 3 to get to 1? What do I raise 4 to get to 1? What do I raise 5 to get to 1? And all those answers are 0. Second one is if the base on the log and the big number next to it are the same, my answer is always 1. If I had log 2 of 2, log 3 of 3, log 4 of 4, I don't have to do any work, right? What do I raise 2 to make it 2? 1. What do I raise 2 to make it 3? 1. Okay, then these look a little bit more complicated than they are, and they're so easy. If the log and the base are the same, if these two are the same, then my answer is the exponent. So if I have log 3 to the 7th, my answer is 7. Long way around that is I could say log 3 to the 7th equals x. Convert it into exponential. 3 comes over, picks up the x, drops off, leaving 3 to the 7th. Now my bases are the same, so my answer is the exponent. Quick mental math says if you see the same base as the big number, cross through them, keep the exponent, okay? So if it had just said log base 3 of 3, what's the exponent on the big 3? 1. So think about it. If these are the same, I can cancel through it, keep the exponent. It doesn't mean it's 0. It doesn't cancel making it 0. It makes it 1. And then the reverse of that is this. If it's in exponential form, so if I had 3 log base 3 of 7, if the base on the exponential form and the base on the log are the same, I can also cancel through those to keep the big part of my exponent log. And again, if you want to see that like written out and rewritten, this is in exponential form. So to rewrite it in log, we do log. The base of the exponent becomes the base on the log. The x comes over with that, would equal log base 3 of 7. And this is what this says. The one-to-one property on log says if the log and the base are the same, then whatever's next to it is equal to each other. So if I had log base 2 of x equals log base 2 of 7, my answer's what? 7. Okay, if these are the same, I set what's next to it equal to each other, just like you would normally do with your exponents. Again, all those properties, the better you get at them, the quicker these mental math things happen. So try to do these without converting to exponential, okay? So look at just this size first. Is there a power I can raise 3 to get it to 81?
4.
4, that's it. There's my answer. Is there a power I can raise 5 to get it to 1?
0.
0. That's it. There's my answer. If you don't see it, then do the conversion, right? So 3 to what power becomes 81. I'd have to change 81 to 3 to the 4th. Then the exponents are the same, okay? But your goal here is to get so comfortable with these that you don't have to go through all that work. So if it would be 5 to the x equals 1. There's no way to do that any other way than knowing that the exponent has to be 0. Yeah, just 1. So I would. All right, so let's see how fast we could do these. Yeah?
You answer 4 equals x or just 4?
Well, I mean, it's going to be fill in the blank. It would just be 4. Yeah. All right, so use the properties of logs to find the answers. Again, for those of you that are like to do things quickly and not show any work, these are where it's at, folks. What is A?
15.
15. The base and the base of these are the same. It's just 15. What is B? 3. The base and the base of these are the same. It's just 3. What is C?
1.
1. 9 to what power is 9? 9 to the first. And D, 3 to what power gives you 1/3? -1. Questions? We good?
So on the homework, if we get a question like that we can do quickly, we don't have to show work? or
That
no?
is correct. That is correct. And then comes the graphs. So we are going to, and honestly, like people freak out, it's so easy. We are going to take our log function, we're going to convert it into exponential, which means our exponent's going to have the y in it. And with logs, instead of plugging in for x like we do for exponential, we just plug in for y. So there's a whole process where you could graph the log or graph the exponential and then switch your x and y values, and that takes so long and it's so confusing. For me, graphs of logs are super easy. We're going to 1, put into exponential form. 2, use a t-chart, but plug in for y. That's it. Then you get your points, plot your points, and your graph for logs, the parent functions look like these, okay? They are inverses to exponential, so they would flip over the y equals x line. But to me, it is way more confusing to plot those points and then have to move them than to just plug in for y. Which means I used to have a horizontal asymptote, now I have a vertical. I used to have a y-intercept, now I have an x-intercept. Okay? The domain used to be all real numbers, now my range is all real numbers. The range used to be 0 to positive infinity, now my domain is 0 to positive infinity. So everything about the x and y is now flipped. Which is what this says. Okay? There is now an x-intercept, not a y-intercept. There's a vertical asymptote instead of a horizontal asymptote. The function is increasing if the base is a whole number, and it is decreasing if it is a fraction. It is smooth and continuous because it's a function, right? It's going to be smooth and continuous, no sharp corners or gaps. This is what I just said about domain, okay? The log function reverses the domain and range of the exponential function. Range of logs are now all real numbers. And the domain of the parent function is 0 to positive infinity, and it shifts with a horizontal shift. So think exponential moves with a vertical shift, logs move with a horizontal shift. You can find the vertical asymptote by setting whatever's inside the parentheses equal to 0. And you find the x-intercept by plugging 0 in for y, which would be part of your t-chart anyways. If you do it in the same order every time, it's the middle point. This one you have to fill in, right?
Yeah.
Okay.
What does the one with the vertical asymptote mean?
So like if you have, let's say, holy moly, writing too fast. Okay, let's say this is my function, right? This causes a horizontal shift, right? Technically that horizontal shift goes 2 places to the left. So I move my vertical asymptote from 0, 2 places left to -2. That's one way to look at it. The other way is simply set the equal to 0, and I get x equals -2, and that's my vertical asymptote.
Oh, so that's just saying whatever's in the parentheses?
Yep. Yep.
So what about if there's nothing in the parentheses?
So then x-
You know that's it's x equals 0, right?
Exactly. All the translations that happen with exponential functions happen with logs. If I add or subtract after the log, it shifts it up and down. Inside the parentheses, left or right, and this is what causes the vertical asymptote. Shifts the vertical. Okay, and your domain. So the horizontal asymptote is what causes that, or the horizontal shift. The reflection this time, if my parent function is a log, it looks like this. If the negative is on the front, it still flips it upside down. So instead of going up and to the right, it's like that. And the negative inside the function flips it over the y-axis or points it left. The x inside changes my domain as well, because now my arrow would be -infinity up to that point. Vertical stretch and shrink are the same. If the number on the front of the log is greater than 1, it stretches it vertically. If it's a fraction, it shrinks it vertically. If it's inside the parentheses, it's a horizontal shrink, which really still means it's narrow, and a horizontal stretch, which really just means it's flattened out. But again, you will plot points to figure out those stretches and shrinks. All right, we're going to go straight here, okay? Because that's what your quiz is going to do. It's not going to ask you to do that and flip it. We can compare them later, but we're going to go straight there. So I'm going to change the g of x to y. I'm going to convert this to exponential. 3 would pick up the y, drops off, leaving the x. I'm going to use my t-chart, but I plug in for the y. 3 to the negative 1, 1/3. 3 to the 0, 1. 3 to the 1, 3. So 1/3, negative 1, 1, 0, 3, 1. There's my log function. Vertical asymptote would be if I set this equal to 0, so x equals 0. X-intercept is where my y is 0, 1, 0. Domain, 0 to positive infinity from my asymptote to the right, because that's where my graph is pointing. Range, all real numbers. If I had graphed the other function, it would have been the exact reverse of the x and y points. But you're not going to put them both on the same graph for the quiz, so you might as well get used to doing them by themselves. All right. And again, instead of using transformations, we're going to plug in points because, again, that's what you're going to do. But think about the transformations when you graph it to figure out if that's what your graph's supposed to look like. So first thing I'm going to do is make g of x, y. Y equals negative log base 3 of x minus 1. Now, before I can convert it into exponential, that log has to be completely by itself. The negative can't stay. So how do I get rid of a negative on the front? Divide or multiply by negative 1, right? So I could divide the whole thing on both sides by negative 1. I get negative y equals log base 3 of x minus 1. So all we did on the right is get rid of the negative and put it on the left. You could have divided or multiplied by negative 1. Now we're going to convert this into exponential. 3 picks up a negative y, drops off, leaving an x minus 1. And then to solve for x, we're going to add 1. Now I'm plugging in again for y. So 3 to the negative negative 1 plus 1. 3 to the negative 0 plus 1. 3 to the negative 1 plus 1. This becomes 3 to the first plus 1, which is 4. This becomes 3 to the 0, which is 1, plus 1, that's 2. 3 to the negative 1, 1/3 plus 1, 1 and 1/3. Now go to your graph. 4, negative 1, 2, 0, 1 and 1/3 and 1. Where's my vertical asymptote? Good. Set it equal to 0, right? So vertical asymptote is at x equals 1. That's where my curve is going to happen. If I thought about the parent function of 3 to the x, it would be like this. This is flipped upside down and shifted to the right 1 unit, which matches what we did. So now my domain it's not 0 anymore, it's 1 to positive infinity. My range, negative infinity to positive infinity. My x-intercept, still the middle point, 2, 0. Questions on that one?
You leave it there for like a good second.
Yeah. So this would be a non-calculator portion question. You would see something like this on your quiz. So one exponential graph, one log graph, and then some questions based on exponential and logs. All right, so first step here is what? Good. Then this in exponential form, 4 picks up the y, x minus 5, and then we want to actually solve for x. So I'm going to add the 5. That's an add 5. And I get, I get 4 to the y plus 5 equals x. Now I plug in for the y. So I get 4 to the negative 1 plus 5, 4 to the 0 plus 5, 4 to the first plus 5. 1/4 plus 5, which is 5 1/4. 1 plus 5, which is 6. 4 plus 5, which is 9. Five 1/4 and negative 1. 6 and 0. 9 and 1. Where's my vertical asymptote? Set this equal to 0. What do you get? X equals 5. Which makes sense because there's my curve. What's my domain? 5 to positive infinity. What's my range? Negative infinity to positive infinity. What's my x-intercept? 6, 0. That is very close to something you would see on your quiz next week. The middle of your, so if you do your t-chart, then the middle one is 0, and you've already done it. So you've already done the work, you just got to find it. Yep. So a log function with e as its base is called the natural log function. Remember we said e is the natural base, right? So the ln on your calculator is for natural log, and ln is the same as log base e. So if I see log base e, I can rewrite that as ln. And if I see ln, I can rewrite that as log base e. They are interchangeable. All it means is that that little base is really 2.7. So if you're graphing an ln graph, it has all the same characteristics as a log graph. It has the vertical asymptote, it has an x-intercept, it has domain that's restricted, and it has range that's all real numbers. Good morning, Mr. Saxton.
Oh, I didn't want to interrupt your
Oh, you're good.
How are you doing? Hi, everybody.
Hi,
No, Cy
Who
Taylor.
said that?
Cy Taylor.
Sai.
That's
He's just, he's staring at your name. All right, so the easy part is evaluate. Use the calculator to evaluate the function at the indicated value. Round your answer to 3 decimal places. So you're going to locate that ln button. It's the one we were using yesterday, which is the e to the x, right? So I would say 2 ln of 12.5, and then literally just type that in and hit enter. 5.051 is how it would round. If you're using a scientific that doesn't store it like your phone, then you're going to do 12.5, then you're going to hit ln, then you're going to hit times 2. So make sure you practice the order on both. So we don't hit second for ln, okay? That's the difference. So the only
did that.
two, sorry, go ahead.
I did that and I got 8 point.
Yeah, I did too. You have to put the 2.5 then I got 5.05.
Wait, are you doing it on scientific, this one?
Yeah, I have the
12,
TI 84.
and you did 2 ln 12.5?
Oh wait, no, I thought you said for this one we have to use.
No.
12.5 first.
The graphing one you do this way, the non-graphing one you do the second way.
Oh, okay,
Yeah,
sorry.
so no, that's okay. So the graphing you go in natural order, okay? exactly how it's written, because that's how it stores it.
Yeah, I just put it that way, I was right.
All right, these take no calculator, which means fair game for quiz. -5 times ln of e. What is ln? Log base
Log
e.
E.
What would be log base e of e?
Why?
It is, yeah. So that's 1. Insecurity in your voice. That is 1, and 1 times -5 is just -5. So when you say ln of e, it's the same thing as 1. ln e equals 1. It doesn't equal 0. It equals 1 because it should be the exponent on the ln. If it was ln e to the second, it's 2. It's the exponent on the e. So if I see e to the ln, this is the same thing as e to the log base e of 7. What's that answer? 7. Okay, so again, ln is the same thing as log base e, so all these same rules apply as before. If it's e to the ln or if it's ln of e, they cancel and you leave what's left. Okay, last example graph, so I'm just going to get it started. This would be rewritten as log base e of x minus 3 equals y. So when you're graphing, you have to change it to log base e because now we're going to convert it into exponential. E to the y equals x minus 3 and e to the y plus 3 equals x. Now it's still a log function, so I am still plugging in for the y. It's just that now I have to use the calculator because I have e. So e to the -1 plus 3, e to the 0 plus 3, e to the first plus 3. Really, the only one you need the calculator for is the first one, but we'll do them all. E to the -1 would be 0.367 plus 3 is 3.4. Remember, when we do the graphs, we only need nearest tenth because you can't graph more accurate than that. E to the 0 would be 1. This is 4. E to the first is 2.7. 5.7. Plot those points. And there's my graph, okay? My vertical asymptote still comes from the parentheses, as is my domain, as is my domain, and then my range is all our numbers, okay? I'll finish the one that I had skipped the extra example on the video. You guys have a great weekend. Your homework for 3-2 is due Monday. Peace out, folks.